Under ideal conditions, a population of E. coli bacteria can double every 20 minutes. This behavior can be modeled by the exponential function. N of t equals n naught 2 to the 0.05 t, where t is the time in minutes, n naught is the initial number of E. coli bacteria, and answer the following questions. If the initial number of E. coli bacteria is 3, how many bacteria will be present in 3 hours? If the initial amount of E. coli bacteria is 6, how many will be present in 3 hours? If the initial number of E. coli bacteria is 6, how many will be present in 7 hours? So before we get started with any of the other values, let's make sure we have an understanding of this model here. So N of t represents the number of bacteria after a certain period of time. N naught, or N sub 0, is the initial amount of bacteria present. So what you start with, the number of bacteria that you start with. And then the rest of this is part of the formula. We have an exponential with base 2. 0.05 is our rate, and then we have t being the time. And it mentions here that time is in minutes. And this is a significant thing to pay attention to, because later when your question is asked, the time is given in hours, which is a different unit of measure. So we need to make some changes in order to use the model that's given. We have to be given time in minutes in order to use that model. So since we're given time in hours, we need to make that adjustment to the proper units. So in part A, the number of E. coli, the initial number of E. coli is 3. So we're going to use the value of 3 in place of N naught. And then our time is 3 hours, but it's in the wrong units. So we need to make the adjustment. So we need to know how many minutes are in 3 hours. So we can change to, so this is hours. We can change to minutes by multiplying 3 by 60 to get the number of minutes. So 3 times 60 would be 180. So when we use time in our formula, we want to use it in terms of minutes. So when we substitute in, we'll do N of 180, and that is 3 N naught, the initial amount of bacteria, times 2 to the 0.05 times 180. So we're going to type that into our calculator. We've got 3 times 2 raised to the 0.05 times 180. And we have, after 3 hours, 1,536 of the E. coli bacteria. So let's continue with the next part. In the next part, we now have an initial number of E. coli being 6. So we're going to use N naught to be 6. We're still looking at how many bacteria will be present after 3 hours, so I can use that same information. That 3 hours is 180 minutes. And so we're finding N of 180. We're going to have initial amount of bacteria being 6 this time. 6 times 2 to the 0.05 times 180. So 6 times 2 raised to the 0.05 times 180 will give 3072. So that's the number of bacteria that will be present after 3 hours if we started with 6 bacteria. In the last part, the initial number of E. coli is 6, and we want to know how many bacteria will be present after 7 hours. So T equals 7 hours. We can change that to minutes. 7 times 60. There are 60 minutes in an hour, and that would give 420 minutes. So we want to find N of 420. And we have an initial amount of bacteria being 6, stated right here, times 2 to the 0.05 times 420. So we'll type in our calculator 6 times 2 to the 0.05 times 420. And we've got 125829112. Let me get some commas so I can say that number. That's 2,582,912 E. coli bacteria present after 7 hours. Thank you for checking out my videos. Have a great day.